As we've seen, when two vectors meet at right angles, the resultant vector can be found using the Pythagorean theorem and trigonometry. The magnitude with the theorem, and the direction using the tangent ratio. But there are other ways of working with vectors. One way is with a grid and ordered pairs. For example, ordered pair 5, 2 describes this vector. Starting from the initial point, we count 5 moves to the right and then 2 moves up. The reason it's called an ordered pair is because the first number in the bracket is always the horizontal move, the second the vertical. There can be any number of vectors described by ordered pair 5, 2. 5 moves right, 2 up, and so on. You'll notice that vectors don't have to be nicely positioned on the intersection of grid lines. They can be placed anywhere in between. On most grids, movement right is positive, left is negative. Movement up is positive, and down is negative. Thus, a vector with ordered pair -4, 3 will be movement to the left and up. Let's put ordered pairs to use in a tense, true-life dramatic situation.
Right away, sir. Charlie, the bulb's burned out at Crocker Lighthouse. Let's see the chart. Right, it's due east of here. Let's go.
What's this about a current?
Oh, don't worry about it. It just says there's a 6-knot current running north out of the channel. But we have to go due east.
The engine's wide open. We're doing 12 knots. So where's the lighthouse?
Well, look, Charlie. The lighthouse is due east. That's where we're pointed. The compass says so.
What's that?
I don't see anything.
That's what I mean. We're running out of water.
Oh, my gosh. It really is flat. Hang on, Charlie.
Well, wasn't that exciting? Maps and charts provide a ready-made grid, lines of latitude and longitude. Let's use ordered pairs to find out what went wrong. The ship was pointed due east, traveling at 12 knots. But, as Ed pointed out, there was a northward current running at 6 knots. These are both vectors, since each has a magnitude and a direction. The resultant is the course the ship actually followed. The two vectors are called the components of the resultant. Taking this one step further, each component can be described by its own ordered pair. The east or horizontal component is described by ordered pair 12, 0, 12 over and none up. The north or vertical component is 0, 6, none over and 6 up. If we add the ordered pairs 12, 0 and 0, 6, the sum 12, 6 is the ordered pair that describes the resultant. Now we know what went wrong. The boys thought they were traveling 12 knots due east, or 12, 0. But because of the current, they actually went east and north, 12, 6, way off course. Let's look at another example. This time starting with a single vector on a grid. At this point, we don't know anything about the vector, so we'll begin by finding its ordered pair. From the initial point, the horizontal component is 4 moves to the left, or -4. The vertical component is 3 moves up, so the ordered pair is -4, 3. Finding the horizontal and vertical components of a vector is called resolving a vector into its components. Both components can be described by their own ordered pairs, -4, 0 and 0, 3. And sure enough, when we add them, the result, -4, 3, describes the vector we started with. But the process of resolving a vector into its components and finding its ordered pair does not tell us the vector's magnitude or direction. But it does give us all the tools we need to find them, our old friends Pythagoras and trigonometry. Now that we know all about ordered pairs and grids, let's do something completely different. Here's a vector. 9 to the right and 3 up. Here's another one, 4 to the right and 5 up. We can see immediately that these two vectors don't meet at a right angle. But we're not going to let that stop us from finding the resultant. First, we'll add the ordered pairs. And we find the resultant is vector 13, 8. What we want to do now is find its magnitude and direction. But we need a right angle, so the two existing vectors can't help us anymore. The horizontal and vertical components will give us a right angle. And we already know what they are because they're right in the ordered pair of the resultant. Now we can find magnitude with the Pythagorean theorem, and direction using the tangent ratio. Let's look at this example once again. We started with two vectors on a grid, added their ordered pairs, and found the ordered pair which describes the resultant. This gave us the horizontal and vertical components. And finally, we calculated the resultant's magnitude and direction.
Why don't you ever listen, Ed? The chart shows a current. Look.
Now listen, Charlie, the chart said due east. I just put her in gear and away we went.
Sure, we were pointed east at 12 knots, but at the same time, the current was pushing us north at 6 knots. So we ended up going this way instead of east.
Well, I guess we should have steered more to the south to compensate for the current.
Listen, Ed, I'll explain it to you. Our ship traveled at 12 knots, so we joined the horizontal vector to the initial point of the current vector and used the sine ratio to find the size of angle theta.